Okay, 10.6, I can use segments of chords, tangents, and secants. So we talked about in the last section, in 10.5, right, that if you have two chords that intersect in the inside of a circle, and we talked about the angles, right? Real quick review, we said that this angle right there is equal to that plus that divided by 2. What we're going to do is we're going to kind of shift gears and talk about the lengths of those segments. And there's some connections between if you have two chords that cross like that. But anyway, it says when two chords intersect the interior of a circle, each chord is divided into two segments. They are called the segments of the chord. So what we're talking about is this one has that and that. Those are the two segments of that chord. This one has that segment and that segment. Those are the two segments of that chord. Okay, this is what the relationship or the connection. What it says is if I take the two segments, I take AE and EB and times them together, that will always equal the other two. So if I take DE and EC and multiply those two together, that will always be equal to each other. So this allows us, if I know 3 of the 4 segments, I can actually find the 4th segment. I can solve for those. So here's an example. I've got, there's one segment and there's the other one. If I times those together, x plus 2 times x plus 1, that has to equal that segment times that segment, which is x times x plus 4. Now we just have this nice equation here we can solve. So let's multiply all these out. So if I distribute, I end up with x squared plus 1x plus 2x plus 2. That has to equal x squared plus 4x. Okay, so now I've got x squared plus 3x plus 2 equals x squared plus 4x. One thing you'll notice in this one is they have an x squared on each side. So what I can actually do is subtract x squared from both sides. And it works out nice because those are going to come out to be 0. I end up with 3x plus 2 equals 4x. So I'm going to minus a 3x over, minus a 3x over. I get 2 equals 1x. So x is equal to 2. That's my answer. You know, the hardest part on that one was solving the equation, but the idea is pretty simple again, is I take that segment times that segment has to equal that segment times that segment. Okay, and we get our answer. Let's do, these are both quite a bit easier, the equations are easier to solve. You guys try these really quick. So pause it and go through it, and then I will work through it. So I know that that times that, so 3x, has to equal that times that, so 4 times 6, which is 24. Divide by 3, so x equals 8. Okay, on this one I go that segment times that, 2 times x plus 1, has to equal that times that, 3 times 4. So 2x plus 2 equals 12, minus the 2 over, divide by 2, so x equals 5. Okay, now we're going to talk about, just like we did in the last section, what happens if the point is outside of the circle. So you look at point P on the outside of the circle. So this is just some vocabulary first. So this is what we call, you know, this line is a secant, like it crosses the circle twice. When it does, it forms two things. This big segment from point P all the way to point R we call the secant segment. And then the external segment is talking about from P to Q. Okay, that's the external segment. So just some vocabulary, you'll see it here in these theorems. This is called a tangent segment, right? This one is not a secant, it just touches. So it comes down here and touches, that's a secant, a tangent segment, excuse me. Okay, so here's our theorem. So what we do is if I have two secants, okay, this is our relationship. This is a little bit tricky, is I take EA. EA is the external segment. It's that piece right there, times by EB. EB is the entire segment, the whole thing. Okay, and that has to equal the same thing on the other one. So it's always the outside piece, the external piece, times by the entire thing, right? EC times ED. So outside times the entire thing equals the outside times the entire thing. That's what that theorem says. So let's do this one right here. I take the outside is 9. And what happens a lot is we times it by the inside, but it's not the inside, it's times by the entire thing. The entire thing is 9 plus 11, so that would be 20. And that has to equal the outside, which is 10, times the entire thing. So that's 10 plus x. Okay, we're just going to work this out. So we got, what, 180 equals, distribute that 10 through to be 100 plus 10x. So minus the 100 over would be 80 equals 10x, divide by 10. So x equals 8. Okay, you guys give these two a try. Pause it and try it, and we'll go through it after. Okay, so I do the outside, 6, times by the entire thing. 6 plus 9 is 15. The outside, 5. And just be careful, do not just times it by x, you have to times it by the entire thing. So the entire thing would be x plus 5. And now we solve that equation. This is what, 90 equals 5x plus 25. So minus a 25 over would be 65. Divide by 5. What is that, 13? Okay, this one gets a little bit trickier. This one actually is going to be a quadratic. So if you got this one, nice job. If not, watch carefully. So I'm going to take the outside 3 times the entire, so this is the outside, times the entire thing. That would be 3 plus x plus 2. Right, that's the entire thing. Equals the outside, which is x plus 1, times the entire thing. So the entire thing, I've got to add those together. I've got to go x plus 1 plus x minus 1, right? I take that plus that gives me the entire thing. So that ends up being what, 2x, and then plus 1 minus 1 goes away. Okay, so let's work this out. This is 3 times, I'm going to add the 3 and the 2 together, so it'd be x plus 5 equals, I'm going to times that 2x through, that'd be 2x squared plus 2x. Times that 3 through, 3x plus 15. Okay, this is where we have to pause and recognize what kind of equation this is. We may or may not remember, this is going back to first try. When you end up with an x squared, it means it's a quadratic equation. So quadratic equations, you want to solve either by factoring or by using the quadratic formula. You can use either of those two methods. If you're going to, either way, you want everything on one side. You want it to be x squared, then the x term, and then the constant term. So I'm going to take this 3x and minus it over to move it over to this side. And I'm going to minus that 15 over to this side also. So I end up with 0 equals 2x squared minus x minus 15. Okay, now I've got it in the right form. I've got the x squared first, the x term second, and the constant third. Now you choose. Either we're going to factor or we're going to use the quadratic formula. If you're going to factor, we reviewed this if you remember at the beginning of the try, there's 2 ways to do it. You can do it with the x method. So if you want to do it that way, you can do it that way. You can also just do it with guess and check. So I go like this. To get 2x squared, I could have 2x and x. To get a negative 15, I could have negative 1 and 15 and negative 3 and 5. And now I just have to try one of those to see which one will work. So I'm going to try the negative 3 and 5. We'll see if I try it this way. Here's how we check to see if it works. We know that 2x times x gives me the 2x squared. We know minus 3 times 5 gives me, we want to check for this middle term. We want to get a minus 1x. So the way you check it is you times the outside 2 and the inside 2. So the outside side 2, that would be 10x The inside 2 would be minus 3x. When I add them together, I do not get a minus 1x. So I'm going to take them and switch them around. So I'm going to put the, let's see, the plus 5 here and the minus 3 here. Try it again. That'd be minus 6x. That'd be plus 5x. I add those together. That gives it to me right there. Hey, that's a factored form now. The last step, if you remember, is you take those factors and set them equal to 0. So we go 2x plus 5 equals 0, and x minus 3 equals 0. So this would be 3 over here. Now x equals 3. This one I'd have to minus the 5 over. 2x equals negative 5. Divide by 2. So you get a negative 5 halves or negative 2.5. Those are my two possible solutions. Now let's go back up here. Remember, we got to make sure both of those work. So if I plug 3 in, what I want to make sure of is I don't get negative numbers when I plug it in, because if I get a negative, it would, this is talking about the length of a segment. It can't be negative. So if I plug 3 in, I get 3. This side would be 5, so we're good there. This side would be 3 plus 1 would be 4. That'd be 3 minus 1 should be 2. So they all come out to be positive. So 3 is good. If you try negative 2.5, I get 3, negative 2.5 plus 2 is a negative 0.5. That can't be. That cannot be a negative number. It's a length. Same thing here, negative 2.5 minus 1. So negative 2.5 does not work, so we cross that off. My answer is 3. So that was a challenging problem, but again, it comes down to, it's not really the geometry we're learning, but it's solving a quadratic, which takes a little bit of time. Hey, by the way, if you wanted to solve this right here using the quadratic formula, x equals negative b plus or minus square root of b squared minus 4ac over 2. You could also use that quadratic formula. You'd get the same two answers. You'd get 3 and negative 2.5. But make sure you check your answer to make sure that it really works. Okay, this is our last example we have. This is really similar to the last one. The difference is we still have this secant line. But now the other side is a tangent line. So if you think about this for a second, what we just did is we said on a secant line we take the external piece, the outside piece, times by the entire thing. We're still doing that. External piece times the entire thing equals, if you have a tangent line, just think about this for a second, that would be the outside piece, but it's also the entire thing. So I go EA times EA, which is EA squared. So if it's a tangent line, the outside piece is also the entire segment. So it's almost exactly the same formula, just looks a little bit different because of the tangent line. So if you look at this one, we're going to take the outside piece, which is x, times by the entire thing, which is x plus 8, equals the outside piece, which is 16, times the entire thing, which is 16. So this is our equation we're going to solve. Go ahead and distribute. This would be x squared plus 8x equals 16 squared. I think that's 256, but I don't trust myself, so I'm just going to double check. 16 squared, it is 256. Okay, now I got to solve that. Again, this is a quadratic. So to solve a quadratic, move everything to one side. So we've got x squared plus 8x minus 256 equals 0. And now it's just a matter of factoring this. This is an easier one to factor because there's nothing in front of the x squared. So we're just going to take the factors of negative 256. We want to find the ones that add up to be 8. I'm pretty sure, we'll double check, I'm pretty sure there aren't any factors of 256 to add up to be 8. That'd be, what, 128. 3 doesn't go into it. 4 does go into it. Let's see, 256 divided by 4. 64. 8 goes into it 32 times. 6 and 7 don't. 9 doesn't. 10 doesn't. 11, 12. I think the next thing is 16. So none of those add up to be 8. So what that means is I cannot solve this by factoring. So I've got to use the quadratic formula. This is good. This is a good reminder on the quadratic formula. We wrote it out a second ago. B squared minus 4ac all over 2a. Come back over here. The a is 1, b is 8, and c is a negative 256. So we're going to plug those in there. I get x is equal to a negative b, so negative 8, plus or minus the square root. I'm going to come back to that, but underneath there I have 2 times a, 2 times 1. Hey, be careful when you find this number. It's called the discriminant. We sometimes struggle with that. I'm going to do it off the side. So I take b squared, 8 squared, minus 4 times a is 1, times c, which is negative 256. So I'm going to take that and plug it in my calculator just to find out what goes inside of that square root right there. So I'm going to go 8 squared. You guys did this all during first try, but again, it's been a while, so hopefully this is helpful to remind you how to solve a quadratic, either by factoring if you can, or if not, by using the quadratic formula. So we plug that all in there, and it comes out to be 1088. You can try to see if you can take the square root of a 1088. I'm pretty sure it's an irrational number. Yeah, it comes out to be 32.98, and it just keeps going. That decimal will go forever. So what I want to remind, this is a good time to remind you, this is a good review, is if you can't solve a quadratic, or if it doesn't come out evenly, if you want the exact answer, you have to take the 1088 and simplify it or reduce it. So let's try that. I'm going to erase this over here so we have some room. So we're going to take that 1088. If you remember, you do your little tree diagram. I think this is the way most of you learned it. We're going to take it and break it apart. So find something that goes into 10,088. I know 2 does. Let's try 4, though. Yeah, 4 and 272. 4 breaks apart to be 2 and 2. Now let's take 272 and break it apart again. Let's see if 4 goes into that again, and choose my calculator to figure this out, and it does. So it'd be 4 and 68. Break 68 apart. I think 4 goes into that again. 17. Hey, 17 doesn't break apart. Oh, sorry, that 4 up there breaks apart to be 2 and 2, 2 and 2. Okay, just what I'm looking for is I want pairs of factors. So that gives me a 2 on the outside. So I have negative 8 plus or minus, and I'm just going to do that part. I have a 2 on the outside. I have another 2 on the outside. I have another 2 on the outside, and I have that 17 left on the inside. So 2 times 2 times 2, 4, 8. 8 squared is 17. That's what that simplifies down to be. And now the very last thing is, if there's a common factor between the 8 and the 8 squared is 17, you can take that out and simplify it with the 2. So 2 goes into both of those. So if I take a 2, take that 2, and take a 2 out of both of those, I'd have 4 and a 4. So negative 4 plus or minus 4 squared is 17. And there's my answer simplified down all the way as far as I can possibly take it. You could plug that in a calculator too and get an approximate. So you know on your calculator, if it does say to find an approximate, you can go ahead and do that. If you notice again, the geometry part's pretty simple, but you may run into some quadratics in here, which may require some factoring to solve, or the quadratic formula. But that's a good reminder for us. It's good practice. This one says, right, the radius of an aquarium tank. So we're trying to find r. So this is a tangent line. So I take 20 is the outside piece and 20 is the inside piece. So it's 20 squared equals. And then I need to find the outside piece, which is 8, times the entire piece. So how long is that entire thing? That would be r plus 8. So that'd be 2r plus 8. With this equation, will be a lot easier to solve. This would be 400 equals 16r plus 64. So minus the 64 over and divide by 16. So if I minus the 64 over, I have 300 and, what is that, 36 equals 16r divided by 16. And that ought to give us our answer. So 336. So 21. I know that's what I wanted to know, is what r was. Okay, we got it, 21. That one was easy because it didn't work out to be a quadratic, a lot less work, right? Okay, I want you guys to try these 3 problems right quick. They're actually all pretty simple. We're not going to do 8. Just try those 3. pause it, and then once you've tried it, come back and watch my solutions. So number 5, I take the outside piece 1 times the entire piece. Don't just times it by 3, you have to times it by the entire length, so it's 4, equals the outside piece, which is x, times the whole thing, which is also x, right? It's a tangent line, so you still x squared. So x squared equals 4. Take the square root of both sides. X equals plus or minus 2. The negative 2 doesn't make sense, so the answer is just 2. Okay, on this one again, you take, 7's a tangent line, so it's 7 squared equals the outside piece times by the entire piece. So I get 49 equals 5x plus 25. So minus 25 over, I think that's 24, equals 5x divided by 5. So 24 fifths, so 4.8, I think, if you plug it in a calculator. Okay, again, this is the tangent line, so square it. The outside piece would be x. The whole piece would be x plus 10. This is going to be a little more work, right, because now I have a quadratic. That's 144 equals x squared plus 10x. So since it's a quadratic, get everything on one side, make sure it's equal to 0. So x squared plus 10x minus 144. Right, I just moved that 144 over to that side, made it a minus 144 is equal to 0. And now we got to try seeing if we can, if it does factor, this should be a pretty easy one to factor. But if it doesn't factor, it might be a little harder. I think it does factor. Let's try it. Right, so what times what gives you x squared? What times what gives you negative 144? So make your list. We want whatever adds up to be 10. So you could do negative 1 and 144. That won't work. You could do negative 2 and what's that? 72. That's not going to work. I'm pretty sure 3 goes into it. I don't think that will work. Let's try, see, I think 4 does. 144 divided by 4. So it would be 4, negative 36. That doesn't work. Let's try 8. 4 goes into it, then 8 probably will. I think this might be it. So let's go negative 8 and a positive 18. That gives you negative 144. When I add them, that gives you a positive 10. So it's minus 8 and it's plus 18. So when I times them, I get negative 144. When I add them, I get a positive 10. So my answer is x equals 8 and negative 18. Right? What makes that equal to 0? What makes that equal to 0? The negative 18 doesn't make sense, right? X cannot be a negative because it's a lane. So my answer on that one, the only possible solution has to be 8. So this can come out to. So again, your challenge will be is when you end up with a quadratic equation. Just remember, you've either got to factor it, and again, if you guys are more comfortable, if you learn the X method, use the X method. If you want to do it the way I did it, that's fine. You should know how to factor. That's the first thing I would try. If that doesn't work, then you can use a quadratic formula, which we already listed on here. Okay, thanks guys.